Hi, good morning. Good afternoon, sorry. I'm Federico. I'm the founder of Evmos, and today I'm going to be talking about dynamic IBC and how it's going to unlock the new wave of dApp composability. So first, a little bit about me. I've been a Cosmos core contributor since 2017. I started working as a full-stack engineer and then made my way into working on core protocol, worked on the IBC interoperability protocol that makes today Cosmos famous. And then I transitioned into building an EVM on top of Cosmos with full interoperability, which is what Evmos offers today. So the main question that we want to answer today is like, why is interoperability relevant and how does it affect developers and also users in terms of user experience? So the main thing that interoperability provides is it allows you to use DeFi Legos. So right now, when we think about Ethereum and different virtual machines, you have different smart contracts or decentralized applications that you can use to leverage one another and build on top of that. So that's what we mean by composability. So you can build a lending protocol by using an oracle and so on. But what happens when you don't have those DeFi Legos is when it becomes problematic today that you need to reach through interoperability to another protocol or to another EVM chain in order to start using those DeFi primitives, those DeFi Legos before you get to start building something. And ultimately, this is a big problem because it's not only a technical problem, but it's also a business development problem because today we have many applications that are deploying on different EVM chains, and that also adds cost to the foundations or to the core development teams that need these basic primitives in order to start building. This happens when you don't have interoperability in place, and that's why interoperability is very important to be able to compose between smart contracts. Then, the second major point of why interoperability is important is because it provides access to liquidity. So today, there are more than 160 EVM-based chains deployed in production, and they have the vast majority of the TVL, the liquidity available in the blockchain ecosystem overall. So what happens today when you have USDC that is deployed in multiple chains? Sometimes you have to reach that liquidity, so that's why today we think that the concept of TVL, the total value lock for a single chain, is not accurate anymore, that we need to expand this terminology to be able to account for all the liquidity that is fragmented and available in other chains and other ecosystems. So interoperability is important to be able to reach that liquidity in the first place. And finally, for composability that I mentioned a little bit before, but also for user experience. So today you have multiple accounts in different networks, different types of EVM chains, other types of VMs, layer 1s, layer 2s, even layer 3s. So interoperability can also provide as a mean to managing different accounts on other networks by composing with one another and being able to, at the end state, send instructions to accounts that you manage from a single main account, so to speak. So that's why interoperability, if we're thinking about the end state of user experience, interoperability is really important to get us there. And so we talk a little bit about the importance of interoperability and how it also relates to user experience, right? So I want to talk about also how interchain user experience today really sucks for end users and how it's really hard for mainstream users to get onboarded to crypto, especially when they have to onboard to different ecosystems that don't have the interoperability in place, or they have to manage multiple accounts. So I'm going to provide a few examples of why this is the case. So the main thing that you've probably seen when interacting natively with different decentralized applications is this, having to change from one network to another, even though you have the same EVM compatible chain and the same address derivation, in this case, the Ethereum types account, or in the case of Cosmos as well on the right side, that you have multiple chains. And this is kind of like, for crypto natives, we're used to that. But for someone that is coming from the Web 2 experience or from a banking experience, maybe even from a neobank, this is completely, like, it blows their mind and they don't know how to get to there. Like, I, as a user, should only know that I have tokens that are located somewhere, and the wallet should be smart enough to be able to understand where to transfer them to. So abstracting that functionality is really relevant when it comes to user experience. And yeah, this is the phase that they come when they come to this environment. They download MetaMask, and it's a pain in the ass for them. So the other thing that I just briefly touched is the token fragmentation. We have different interoperability solutions with different layers of securities, different levels of decentralization, different levels of governance. Some of them are multi-sigs, validator secured, consensus secured, plain multi-sigs, and also like client base, like protocols, like IBC in the Cosmos ecosystem. So that naturally leads into token fragmentation. So in terms of, if we're talking about interoperability US, this is one of the main pain points for the end user. And as I said before, the user should only care about having USDC or having USDT and not having the single, like every specific denomination in their wallet. And then we get into different formats, right? Like, we talk about native tokens, we talk about ERC20 tokens, and then there's different standards in, like, Tron, etc. They're different. So how do we make the tokens compliant with each other, and how do we create interoperability so that it supports, like, ideally one standard or one specific format for the tokens? And don't get me started with NFT, and that's also like a different point. I'm not sure, for example, in Cosmos that we've come with a specific standard for that yet. So then the other main problem is, like, when it comes to, and there was a talk right before this downstairs about the standard for custom messaging interfaces between EVMs. So trying to standardize the different bridge implementations into something that is more, that can be abstracted, and so that we can provide better user experience overall and better developer experience, so that we can share this implementation overhead. But the reality is that it's not, there's not a standard implemented. If we look at the reality, there's, like, the race, as I call this race of application specific interoperability that was supposed to, I guess, try to solve this issue by having CCTP, CCIP, wormhole, Axelar GMP, so different implementations of bridging technologies. And so for some time, there was hope that applications will come to terms in sort of like leveraging each other's technology and leveraging each other's open source code to create a real standard for interoperability, or for bridging at least, in the EVM world. But if we start looking at the different implementations, we can see that, for example, wormhole defines a target chain, a target address, payload, which is the data that we're calling on the counterparty chain, receiver value, gas limits, and it returns a sequence. Same with CCIP from Chainlink, receiver, data, fee token, extra arguments, and also with Circle's implementation. It's more or less the same, but you can already see the similarities between these different implementations for sending a cross-chain message. But the problem is, like, first, they cannot even agree on the single type for addresses, or payload, or even the arguments like order that will create a different function signature on Solidity or in the AVI. So this creates a lot of complexities even for a full standard to be implemented, because, like, even the ordering is different. It's going to create a different AVI signature. So like, there's nothing else to say that, well, how can we create a better interoperability protocol, or how can we create a better structure that is able to provide with better security, with better governance, with more outreach interoperability, et cetera, that can abstract the different application-specific interoperability into something that is more robust and more secure. And just to highlight again, this is not a technical problem. This is a business development problem more than anything else. Because the standardization is something that we need to agree off-chain, and it's not something that can be implemented in one way or another. It's a business development problem. But Cosmos is here to help us, right? There's like this amazing standard called Inter-Blockchain Communication Protocol, or IBC, that is able to, via light clients, generate miracle proofs of inclusion of the transaction, receiving acknowledgements, etc. So what about IBC? So IBC, for the ones that are not familiar with it, basically works under two different layers, which is IBC transport, which here it's represented as TAO, or transport authentication and ordering layer, so that you can provide the clients, the connections, and the channels, and then you can order the channels accordingly. And then you have the application layer, basically what you built on top. So the end user applications, or the application-specific logic that is interoperable via this protocol, that relies on this transport, authentication, and ordering. So in reality, it looks like this, but this is really complex already for an Ethereum developer, for an application, because you need to define IBC clients, basically maintaining the light client state and the consensus state for the counterparty chain. Then you have the connections and the connection between the two chains, and the channels that define the connection between the specific parts of the state. So it's smart contract with smart contracts, not only chain with chain, which is what connections abstract, what connections define. So at this point, I lost most of the Ethereum developers when I try to say this, because all they want is something that they can define and is fully abstracted for them, so that they can define send packet or send an arbitrary message to a destination chain with a recipient address and some payload data. So this is a visualization of how IBC works. Basically, you have like a module, or in this case, in Cosmos, a part of the state that it talks to another part of the state, and for this you need encoding. Basically, the message that you're sending cross-chain needs to be encoded and decoded to be able to understand the logic behind it and be able to define the conditions for it. So, for example, if I'm sending a transfer between chain A to chain B, I'm sending a payload defining the sender, the recipient, a token with a specific amount, and some fee, if necessary, to the one relayer, which is this actor that is maintaining the light clients updated. But what about developer experience? I mean, we've talked a little bit about how IBC is one of the most robust interoperability protocols in the ecosystem today, but it hasn't been able to reach to the developer, like application developers. It's only able, right now it's mostly applicable to chains interacting with other chains, like layer ones with layer ones, and not layer ones with smart contracts, or vice versa, or smart contracts with smart contracts, like to have full interoperability across the multiple layers of the state. So I want to leave this feedback here that Adi, who is one of the main researchers from Informal Systems, one of the main contributors to IBC, left in this forum, that these IBC abstractions are really relevant. So maintaining the light lines, because they're relevant for the security guarantees of the IBC protocol, but they demand too much effort for developers to understand, to start building, and right now they're necessary before you can start shipping something. So it's not like on smart contracts oriented VM, that you can build a smart contract, deploy it, and the chain while the chain keeps running. Here, in order to build an IBC connect or an interoperable application, you need to build an entire module, perform an upgrade, and then launch your logic. What about having these interoperable smart contracts be able to be shipped faster and accelerate the piece of innovation when it comes to interoperability? So for this we are introducing dynamic IBC, which is this concept of having dynamic packets so that smart contracts can be able to send cross-chain messages with the same security guarantees as the most popular interoperability protocol in the ecosystem today. So basically what dynamic IBC includes is sending the packet and receiving the packet logic. I'm going to go into that in a second. So why is dynamic IBC important to the ecosystem? So it provides complexity abstraction for the end developer so that you can just define the same packet data as what you can find on traditional bridging structures. It can accelerate the innovation of interoperability and composability. It can provide better user experience by accessing DeFi Legos, building composable dApps, and abstracting all these end-user complexity in order to build better user experience and better products. It provides the security guarantees of like client proofs, and you can also, applications can be built that are fully interoperable, which was something that was not possible until today. So in terms of dynamic IBC, there's the main parts of dynamic IBC is be able to send a packet with some data payload that the application itself, the smart contract, defines, and then callbacks. So being able to receive the data, to receive a packet coming from another chain, and being able to decode it into something that the application can interact with. So for this, one of the main critiques to the IBC protocol and interoperability protocols in general, to be able to have native interoperability between different EVMs, or different VMs, sorry. Some of them support interoperability encoding via JSON, and some of them support AVI encoding, RLP encoding, JSON, gRPC, etc. So the encoding format is relevant for the applications to be able to abstract this functionality and create and understand the logic that is being sent or received. So we're introducing, as part of dynamic IBC, JSON EVM extensions to be able to connect, for example, EVM smart contracts with Cosmos Wasm smart contracts, which is one of the other main VMs available in the Cosmos ecosystem, and also AVI to AVI encoding to be able to have true interoperability between smart contracts on the EVM layer. So going back to the issue around different interoperability implementations, different bridge solutions, is that all of these can be abstracted with dynamic IBC. So you can build the same packet data, so target chain, target address, payload, receiver value, even tokens and fees, abstracted into the packet data. So everything that we have here can be built on top of the basic interoperability layer, which would be dynamic IBC. So this will make it easier for developers to onboard, easier for application-specific interoperability, bridging solutions, etc., that are already built, that are used by major institutions like Chainlink or Circle, and can be abstracted in a way that applications can define their own interoperability logic. So I talk a little bit about the sending logic. What about the receiving logic? So the callbacks functionality is related to the actor functionality, in that basically you allow the contract to receive the encoding data and abstract the functionality, run the execution for the packet data that is received, and then return a value. So this basically what it enables in concrete terms is that you can compose with other chains and being able to handle the acknowledgement so that success or receive acknowledgements from or even timeouts are properly handled on the application layer. So no matter if the cross-chain interaction is successful or fails, you can even handle those cases. So, and this also is built on top of our EVM extensions, which are stateful precompiled contracts that are able to define this functionality and have smart contracts interact with native code in Go that we are already using on mainnet to interact with the staking logic, and we're also building other cool functionality to interact with cross-chain applications or cross-chain application-specific blockchains. So at Evmos, we're building the interoperability layer, these interoperability solutions as a way to provide a better user experience and composability, being able to provide better onboarding and being able to provide more usability for applications than what other EVM-compatible chains provide. So, and a main point for this is also being able to have omni liquidity. So applications being able to talk to one another and reach liquidity that is not available on the native chain, but they can interact with a DEX that is, for example, deployed on Osmosis or another EVM-based chain, and swap and then get the tokens back. So this is crucial for user experience so that the user doesn't need to change their wallet or doesn't need to transfer the tokens to the chain that hosts the DEX, perform the swap, and then transfer the tokens back to the originating chain. This can all be abstracted for the user and built using a single transaction with the same user experience that they're used to in EVM-compatible networks. So Evmos is trying to deploy all this functionality in order to become the Ethereum canary chain, offering all these amazing user experience and interoperability solutions so that developers can try out without any risk all these new features that we're deploying for them. So account abstraction, passkeys, interoperability solutions, and dynamic IBC, of course. Thank you very much, and I think we have 1 minute or so for questions.
Okay, thank you very much, Federico. Yeah, we have roughly about 3 minutes for questions, so if anyone has... Yes, you, sir.
Thanks for a great talk. I think important topic of interoperability. I had a bit more precise question about your IBC. So I imagine you are somehow trying to connect the, let's say, Cosmos mainnet main chain with the Ethereum main chain. Mm-hmm. And for the IBC protocol to work, you need to align somehow the validator set, the authorities who are finalizing the blocks, let's say. So how do you do this in practice if Ethereum has so many validators and so on?
So there are different teams that are building light clients for Ethereum that can basically provide the same Merkle proofs as that IBC requires. But for that you need, as you said, economic finality in order to do that, to be able to verify the light client proofs, etc. So there are different. The team that is working on this is called Polymer, and basically you define different security guarantees for your light client configuration, whether or not you want checkpointing or economic finality. So how many validators have committed to the recent round, etc. So that you can basically parameterize the light clients in order to, according to your risk profile.
Thank you. Any other questions? Oh, yes. Go ahead.
So on the same subject then, how expensive it is to validate a light client proof on Ethereum from Cosmos?
I don't have the data of how, because it hasn't been implemented yet on mainnet. There's only been a few testnet integrations. But our goal right now is to try out this technology in the Cosmos ecosystem. There are many EVM-compatible layers, EVM-compatible networks that we're going to be trying to partner with, specifically because we built the EVM for Cosmos. And trying to build out this technology, there's also Agoric, which is building a JavaScript-based VM, Cosmos Wasm that we mentioned before. There's an Avalanche-based implementation that we can also talk to, and being able to compose across the different chains. And then once we have interoperability solutions with Ethereum mainnet or even layer 2s, because there's being a new request for proposals from the Optimism team to being able to implement IBC for the OP stack. So that will also bring interoperability to layer 2s directly with IBC.